Proving the unit circle trig identities. So let's draw up our unit circle. We'll let our axes in. And so our unit circle has a radius of 1, and we're going to drop a perpendicular here. And we're going to call this angle theta. We'll call this distance x and this distance y. And let's write some things down. We know using Pythagoras that x squared plus y squared is going to equal 1 squared using our right angle triangle. We also can use some trig ratios. So we know that sine theta equals our opposite side, y, over our hypotenuse 1, and cos theta equals our adjacent side, x, over our hypotenuse 1. So this means y equals sine theta and x equals cos theta. And we know x squared plus y squared equals 1 squared, which is 1. And we can substitute our x is cos theta in here and our y equals sine theta in here. And we actually get a special result that sine squared theta plus cos squared theta equals 1, which we call a trigonometric identity, and we can use this to prove many equations we're going to look at later on. But from this we can actually get 2 more identities. So let's divide every one of these terms by sine squared theta. So sine squared theta divided by sine squared theta gives us 1. Cos squared theta divided by sine squared actually gives us cot squared theta. And 1 divided by sine theta gives us cosec squared theta. And that's another trigonometric identity. So here we've got our first trigonometric identity and our second trigonometric identity. Let's go back to our original and divide every term, this time, by cos squared theta. So sine squared theta divided by cos squared theta gives us tan squared theta. Cos squared theta divided by cos squared theta gives us 1. And 1 divided by cos squared theta gives us sec squared theta. And that's our third trigonometric identity. So we're going to use all 3 of these trigonometric identities a bit later to prove some statements if they're true or false.